My name is Jack Elston. I'm with small business in Boulder, Colorado, Blackswift Technologies. We work primarily on unmanned aircraft systems for scientific applications, and some of our recent efforts have been in volcanic monitoring. We work with some really great people to help us to get into this field. It's been largely funded through NASA SBIR, so kind of a plug for that. I mean, a lot of people are asking about how NASA can kind of help out with the work that's being done. And one of the ways that they could definitely do it and have in the past is through the Small Business Innovative Research Grant Program. Recently, it's shifted a lot towards very much the focus on the moon and urban air mobility. And if the scientists could push to get a little bit more of that back towards actually using unmanned aircraft systems for science, that'd be awesome. That's how we funded a lot of this work that I'm showing on my slide here. We started out by doing observations in Hawaii over Figure 8. And some of the maps that we generated are shown there, thermal. We did thermal, we did visual, we did elevation maps, and we also combined that with trace gas measurements, particle sizes and counts, pressure, temperature, humidity, relative, or the 3D winds, along with sample cassettes that we sent off to be analyzed in a lab. You can see a picture of the payload up on the upper corner of the slide here. As you can see, we crammed a lot of stuff into a very small space, and then we added our own logic to be able to put that all together, record it, exactly what time and what location, what orientation of the aircraft, every data point was taken at, so it was very easy to post-process. And then we put this on our S2 aircraft. You can kind of see in the picture in the background there. It's an easy portable 5-pound payload aircraft with a very large payload volume. It can fly for up to 2 hours if you add additional batteries to it. And it can be very responsive. We were able to take this on, for instance, as luggage on commercial aviation, which makes it a lot easier to get places and be responsive to events. We're working with an incredible team again to go and do these observations out in Alaska and Aleutian Islands. I got pushed off from this year, unfortunately, a year because of COVID. But you can see a list of all the different instruments that we're throwing on with that. And we're working with not only NASA this time, but also Christoph Kerner, Angie at USGS, and then Matt Fladlin and Florian have been helping us out quite a bit at NASA to get this off the ground. It involves beyond line of sight flights and a lot of the different technologies that we're really kind of pushing the envelope with UAS. So we're pretty excited to do that. The S2 is a very capable platform. It has swappable payloads. So if you guys have some ideas as far as what we want to put on there, I know Andreas talked earlier about the mass spec. That'd be a great thing we'd love to throw on there if we can make it work. And we're also working on a vertical takeoff and landing version of this, so you don't need to use the launcher that you can see in the background there. Thank you. Appreciate it.